I think in the first session you had a short overview of very specific items, and you also had an overview of what's happening on European level. My presentation will zoom a little bit out of that story. And, well, basically, we spoke a lot about the energy system and how buildings can play an important role in that. And I think we're all familiar that we are moving towards a much more decentralized and renewable energy system. And I think this graph, bottom down, explains very well what it is about. So at certain moments, due to the very volatile renewable energy, we have very high peak prices because, well, due to high energy demand and not much availability of renewables and so on. So the question is, how can buildings react on that? So that is the first evolution or trend that we're noticing. The second, it was mentioned before as well, that there is a uptake of power load growth. First of all, due to electric vehicles, I think Dr. Bob mentioned 40% increase, but also more and more heat pumps will be installed. So there will be continuously increase of power load. So how do we handle these increasing peaks as well? And then this one is a very interesting, is that if we go and see the availability and the viability of photovoltaics and storage systems, there was an interesting study from the Deutsche Bank, the German bank, that studied that there was grid parity in almost half of the countries that they researched. So grid parity means that the total costs of alternative renewable energy systems are equal to the standard energy systems as we know them as today. And what is very interesting, and everybody probably knows this guy from Tesla that does this very well marketing approach, but in Europe we have very much, well, we have a large amount of battery producers as well. But what we notice is that there is a very steep price reduction from the battery, and that is interlinked with this electric vehicle come up as well. You see that in 3 years' time, prices went down to half of what they used to be in 2013. So that is really something to keep an eye on. And if you watch to a specific case, and this is the case for Germany, where you have the black line is actually the electricity cost for household, with the dark green line low, the electricity cost for PVs, that you see that already a few years ago, the price for PV went lower as the price for electricity for households. So there you had grid parity already. And you see that you have as well a prognosis of grid parity for PV and battery combination in a few years from now. And there's really this idea raising at experts that in a few years from now there will be grid parity for the combination of PV and battery systems throughout all of Europe. Because as we know, Germany is not the most sunny climate of Europe. So that was a little bit what can smart buildings bring to the system, but we also have to think what can smart buildings bring to the owner or to the people living there or the people using or in the offices. And I think that's something that we saw in the past decades, where home automation was something a few decades ago for, well, James Bond movies, but now with the internet and the connected homes, we really arrived to these ubiquitous homes that actually react and interact with your preferences. For example, I myself have a smart thermostat, and my heating system knows when I'm not there, so it switches off. My heating system also knows automatically, depending on the outside temperature, how much time it needs to warm up. So that's really making it profitable for everybody. And, well, I was here in the hotel upstairs. I wanted to go to my balcony. I saw this sticker there, and please keep balcony door closed when the air conditioning is on. Well, with a decent system, and it's already done in quite lots of hotels. If your door is open, your air conditioning is shut off automatically. So this is a very practical case. How we should solve the problem of not having children on the balcony, that I don't know. So there is this Internet of Things, and it's really technical, mature, and commercial viable. And you see that a lot of small companies are popping up, big players are jumping on it. And this graph shows the amount of people on this planet, but also shows the increase of appliances connected to the grid. And it goes from smart thermostats, as I just mentioned, alarm systems to open your garage door, and, well, I don't know if they're really usable, but systems of having warning signals if your plants are drying out. So if I hear this beep, it might be my plants telling they are thirsty. But this allows for lots of business models to be developed. And for example, I make the link immediately with electric mobility. As I spoke a few weeks ago with a company that is providing actually platform to those people that have electrical charging points at home that can give access to strangers. And this platform is a little like Uber or Airbnb, providing the whole system like to finance that and to set out the technological work on that. So from BPIE, what did we do? Well, we said we need to set out what are the principles behind smart buildings. And so we have this publication for free available on our website, where we point out 10 principles that are there and needed for buildings really becoming micro energy hubs. And it goes from having your interconnection with your electric vehicles, being part of the district, having as well your dynamic energy pricing. And what we say is that all of them are very important separately, but actually being holistic, considered together, they are much stronger. And apart from principle 1, the sequence is not a level of importance, but the first principle is energy efficiency, and that is the most important to be implemented first. And I will continue a little bit on that aspect. So I just mentioned that buildings are becoming micro energy hubs. We also hear a lot of time the wording prosumers, combining consumers and producers, but we don't like that too much. So what are these micro energy hubs? It's combining the production of renewable energy. It is the ability to have your demand response and to store energy. And not all, of course, not storing only energy in electrical batteries, but as well you can store your heating in heat collectors or even in the heat captation of your building as such. And the crucial aspect of this, where buildings are really the nexus of this combination, is that all of this fits in the story of the energy efficiency. We never can lose that when we talk about the 3 others. And this is a little bit an explanation what is behind. I think this peak we saw in different shapes and formats already today. We also saw that you can do demand shedding. That means that at a certain moment, at peak period, you lower down your energy consumption, that you decrease your peak. You can also shift your demand by using your energy storage, or you heat your building before peak time, or you cool your building after the peak time. You can also have your on-site renewable generation, and on industrial level it happens a lot with cogeneration plants, for example, based on biomass. But then the last one is the energy efficiency. And what is important here is that by increasing your energy efficiency, you're actually lowering your baseline where everything starts from. So therefore, this is really important to take into account when we talk about smart buildings. So recently but the European Commission launched the Building Stock Observatory, but from BPIE we were coordinating that project. And it's for those that are not familiar with it, go and have a look. It's really a website where all building related data is gathered. And for example, this kind of data we take out of it. This is a story of how the building envelopes, how they are performing across Europe, or what is the building envelope level across different countries in Europe. And it is logical that the more northern countries have more insulation than the southern countries due to the climate. But if you go a step further, what we also found from data in the Building Stock Observatory is the final energy consumption, the real energy consumption. And there you see that it goes a little bit the other way around, which seems logic as well. Well, you have some, I'm myself Belgian, so it hurts a little bit in my eyes having this red spot over there. But you also have some other countries that point out clearly where there's a higher energy consumption. And you could say that Portugal and Spain and Greece and Bulgaria are doing very well. But it might be a little bit misleading as well. And I think the next one shows very good where it's misleading in that sense that this is closely linked to energy poverty. And I think it was mentioned by the European Commission that this is a topic also to be tackled in the new legislation. This is the ability to keep your home adequately warm. And so there you see that the countries that were scoring very well on low energy consumption, that a lot of people are not able to keep their homes adequately warm, which is strange for a climate like that. But it is, or it could be direct or indirectly linked to economical situation. So if the economical situation goes better, then the final energy consumption might be more negative as well. Unfortunately, I'm not able to show here, a map of the energy performance as it is designed, because there doesn't exist yet a European database for EPCs. Some countries have a database for EPCs, and there you can then take out what is the designed level of the building stock, but that doesn't exist on European level yet. So this energy efficiency, I think with the nearly zero energy buildings, it ends up coming up with a lot of attention on renovation of buildings. I think this slide for me is very important because this tells a little bit the tale where we need to go to. This is based on a research in Belgium followed by the University of Ghent, where they monitored around 80 social buildings or houses that were renovated to a very low energy building level. And on the horizontal X, you see the normalized design heat use. And on the vertical, you see the actual heat use. And you see that all of them are below 40 kilowatt hours a square meter annual, so which is quite good. Those dots in red, they consume in reality more than double what is designed. In orange, they consume more, but not more than double. And in green, they consume less than what is designed. And what is the conclusion of, well, one of the conclusions of this research is that 1/3 of the building, they consume almost half of the energy demand. So this is a question. So how are we able to track these buildings? Because something must be wrong there. And for this particular case, I don't know what is wrong here, but I spoke with a social housing company a few months ago, and they had the example that they also monitored the energy consumption. And they noticed that a family, an older couple, 65 and plus, they consumed more than double electricity than all the rest. And they went deeper into the topic, and they talked with them, and they said, and the final conclusion was that they actually received a dishwasher. And in the past, when they drink their 4 o'clock coffee or 4 o'clock tea, they went and washed their dishes. And so what they did more or less 6 to 10 times a day, they put it on their dishwasher. So these kind of things can come out only if you monitor your energy consumption. So that's also part of the smart building aspects. I think we need to empower really the building occupants with management and monitoring the real-time energy consumption. Because if you don't measure, then you don't know if it's really consuming as is promised. And these are some screenshots from a private company with who we are working together on real energy consumption database setup. And it goes from trends development, but it also can give signals on moments that your heating system is using more as it used to be. And this is a little bit directly linked to what the Commission also is proposing under monitoring your systems and replacing maybe your inspection schemes. One tool, for example, that this company offers as well is it provides to its clients the best suitable energy provider according to prices and what their behavior. So if you take a little bit a more deep scope in the relation between energy efficiency, demand response, and interaction with the grid, there is an increasing interaction with the electricity market according to the use. So you start with your energy efficiency, there is no interaction, but then you have your time of use energy or your daily peak load management. So you have, for example, in Belgium, you have in the weekends your electricity prices are lower, but you need this real-time demand response capacity. And to do that, you have an increasing level of granularity of control, but you also need to measure much more in detail. So therefore, dynamic price mechanisms combined with smart metering is essential to be able to go to real-time demand response. I spoke a lot about electricity. I don't want to forget about heating as well. And of course, district heating, it's something that is more used in certain countries. In other countries, it's not that much the case. But also in district heating, there is a lot of evolution happening. While we had the first generations, which are moving now to third and even fourth generation. And there we see here on top this curve of the temperature level and the curve here of energy efficiency. And what is interesting, if your energy efficiency increases, it gives you possibility to have a lower temperature level, which makes your system much more efficient. And then it becomes really fun. Because from the moment that you are on the fourth generation, and actually your buildings don't only take the heating from your from the district heating, but you also can become a producer. Imagine that you have solar thermal panels, you have a heat pump or photovoltaics, and it's a sunny day and you're not heating your buildings, you don't need your heat, you can place it on the grid. And I think Stefan mentioned, or we will maybe mention it later, but for example in Denmark you have supermarkets that have waste heat from their fridges that is being added on the district heating network. So what the story that we actually like to tell here is that buildings are really leading this way to a decarbonized energy system where the 3 biggest polluters, which are the buildings, the transport sector, and the power sector, actually combined into one. So I think, as here being as Concerted Action EPBD, we have a crucial role in taking up this whole system. And maybe to end, just 2 practical examples. This is the Edge office building in Amsterdam. It consumes 70% less electricity than comparable buildings. But at the same time, it is very smart in that sense that if you arrive there in the morning with your electric car, you know where you can park, you know in which office you have to work, you know the office knows which temperature you prefer, which kind of lighting you prefer, and actually in their next update, they even know how much milk or sugar you want in your coffee. Very smart. But then it goes, and this is a project under development, but I wanted to highlight it because it's a new project. It's always fun to see some new things. In the smart district of Aspern in Austria, not far from Vienna, they're setting up this smart building testbed for both residential and non-residential. And they're grouping all these elements of smart buildings that we mentioned today, from smart buildings, self-learning control, dynamic and self-learning control systems, PV, battery storage, and so on. But what is the most important here is that they are aggregating all of this. Because I think it's mentioned before, but as a small player, as a small residential or single family housing, the interest of joining a demand response activity is quite low. But if you have this aggregator setting up this system, or if you're joining multiple actors in a district-wise, and even with modern technologies, it can be even national or even European-wise, then you are ready to set up this, this smart building outset for districts. So just to conclude, we have this 10-principle report here. Next week we will launch another report on a similar subject. They're all for free available on our website, and if you don't want to miss it, I invite you to subscribe to our contact list. And I think I thank you, and I hear you later.